How would just 2 degrees of warming change the planet? The Earth is home to a range of climates, from the scorching dunes of the Sahara to the freezing ridges of Antarctica. Given this diversity, why are climate scientists so alarmed about a worldwide temperature increase of just 2.7 degrees Fahrenheit, 1.5 degrees Celsius? Changing the average temperature of an entire planet, even if it's just by a few degrees, is a big deal, said Peter Domenical, a paleoclimate scientist at Lamont Doherty Earth Observatory at Columbia University in New York. A person living in any one location can experience huge changes in weather and even in climate, but those are often compensated by changes on opposite sides of the world, Domenical told Live Science. Is global warming melting Antarctica's ice? Right now, the world is about 2.1 degrees Fahrenheit, 1.2 degrees Celsius, warmer than it was during pre-industrial times, Domenical said. The 144 countries participating in the 2016 Paris Agreement announced that the world should limit the global increase in this century to 2.7 degrees Fahrenheit, 1.5 degrees Celsius, a stricter limit than the former goal of a 3.6 degrees Fahrenheit, 2 degrees Celsius, increase. To put 2.7 degrees Fahrenheit into perspective, just about 9 degrees Fahrenheit, 5 degrees Celsius, separates the modern world from the last ice age, which ended about 15,000 years ago, Domenical said. During that time, sea levels were about 350 feet, 106 meters, lower than they are today, because an extensive amount of water was stored as ice at the poles, he said. During that ice age, about 32% of Earth was covered in ice, compared to just about 10% today, according to the National Snow and Ice Data Center. Earth's climate changes over time, the last ice age is evidence of that, but it's the rapid rate of change and the amount of the greenhouse gas carbon dioxide filling up the atmosphere that have scientists concerned, Domenical said. Moreover, global warming doesn't just increase temperatures, it also threatens the food, water, shelter, energy grid and health of humans, he said. Climate change affects the ecosystems that provide food, and therefore our security of food is linked to the security of those ecosystems, Domenical said. The oceans, for instance, provide people with about 20% of their dietary protein, Domenical said. However, ocean acidification caused by climate change makes it difficult, if not impossible, for thousands of species, including oysters, crabs and corals, to form their protective shells, which in turn disrupts the food web, Live Science previously reported. On land, an increase of 3.6 degrees Fahrenheit, 2 degrees Celsius, would almost double the water deficit and would lead to a drop in wheat and maize harvests, according to NASA. Northern latitudes may see a temporary boost in soy and wheat farming, partly because of the warmer temperatures farther north and partly because increased carbon dioxide helps plants grow, NASA said. But at an increase of 3.6 degrees Fahrenheit, 2 degrees Celsius, this advantage almost disappears for soy, and entirely vanishes for wheat, NASA reported. If temperatures get too hot when these plants are flowering, their growth can become stunted, leading to decrease to or no edible food crop, such as corn or grain, NASA said. How often do ice ages happen? Shelter. As temperatures warm and glaciers melt, the corresponding sea level rise can destroy homes and cities. About 40% of the world's population lives within 62 miles 100 kilometers of the coast, Domenical said. In 2010, more than 123 million people, or 39% of the United States population, lived in counties touching the shoreline, according to the National Ocean Service. Collectively, that is the single biggest investment at risk due to climate change as sea level rises, Domenical said. From 1901 to 1990, the average global sea levels rose about 0.04 inches, 1.2 millimeters, per year, but from 1993 to 2010, the levels rose about 0.11 inches, 3 millimeters, a year, meaning the rate of rise more than doubled, according to a 2015 report in the journal Nature. Energy. About 7% of the United States electricity generation in 2013 came from hydropower, which accounted for 52% of the nation's generated renewable energy that year, according to the Department of Energy. However, reduced snowpack and shifting rainfall patterns may reduce hydropower in the long run, Domenico said. This is now threatening the American West and some European areas as well, he said. Health. Increases in temperature and changing rain patterns are associated with the spread of vector-borne diseases, which another organism transmits between humans or from animals to humans, such as Lyme disease and malaria, Domenico said. Even if a vector-borne disease, is eradicated locally in a particular region, the weather changes associated with climate change can lead to migrations of these vector-borne diseases to new regions, he said. Furthermore, because of health concerns, some regions of the globe, such as parts of the Middle East and the American West, may become inhabitable to humans because of extreme temperatures, Domenico said. That's because humidity often increases with the heat index. When both are high, the human body is unable to evaporate sweat to cool itself. If you're unable to evaporate sweat, you can actually die from exposure, Domenico said. Extreme temperatures can also lower productivity among workers. According to a 2014 Bloomberg report on the economic risks of climate change, extreme heat, especially in the American Southeast, may lead to a 3% drop in outdoor worker productivity, including among people who work in construction, utility maintenance, landscaping and agriculture. This drop is twice that of the productivity slowdown that happened in the 1970s, which likely occurred because of high inflation and economic instability, the report said. All of these threats are just around the corner, Domenico said. The Earth is anticipated to exceed the 2.7 degrees Fahrenheit, 1.5 degrees Celsius, milestone in about 15 years, between 2032 and 2039, Domenico said. The planet is expected to surpass the 3.6 degrees Fahrenheit, 2 degrees Celsius, benchmark between 2050 and 2100, he said. If we're on our current emissions scenario, it's even sooner than that, he said. Even over the last 8,000 years, we haven't seen a temperature extreme this rapid and this fast and large.